So now what did I say friction is? Or what do you think friction is? According to your own definition, what's friction?
Friction is a movement
Uh-huh. It's a
from one place to another.
It's a movement from one place to another. So if I move like this, from this point to that wall, that means that is eh?
No, sir.
Okay, let me just tell you. It's the force that resists or oppose movement. It opposes what? Movement. It's not the way you define it. It opposes what? Movement. Okay? When two surfaces are in contact. That is what this is trying to tell you is that for friction to occur, there must be what? There must be two surfaces coming in contact. Do you understand? For friction to occur, two surfaces must come in what? Must come in what? Nofisat.
Sir.
Did you hear what I said at all?
Sir, I can't hear clearly.
I said for friction to occur, two surfaces must come in contact. Do you understand?
Okay.
Two
Yes.
surfaces must come in contact. And those surfaces will be what? Will be opposed. There's a force that opposes the what? The movement of those two surfaces. There's a force that opposes the what? The movement of those two surfaces. So now for friction to occur, there must be what? The presence of what? Two surfaces. That's what they are saying. You understand it?
Yes, sir.
Let's do that definition and move on. So now, what did this one? But they said it's the force that resists or opposes movement when two surfaces come together. It's the force that opposes or resists what? Movement when two surfaces come together. Before now, we talked about forces, right? Before this friction, we talked about forces. What are the two major types of force that we have? What are the two major types of force that we have?
Sir?
What are the two types of force that we have, or two types of forces that we have?
Sir, I'm not there when you treat force.
I know, but you don't have any idea, ba? So
Yes.
now, there are two major types of forces. We have the contact force and the what? The non-contact force. What did I say?
Contact force and non-contact force.
The contact force and non-contact force. Okay, those are the two major types of what? Of forces. Okay, so now contact force has to do with what? The push and pull. Contact force has to do with what? The push and pull. What did I say? The push and what? And pull. Do you understand it?
Yes, sir.
Now, when you push, there's a contact, there's a force, there's an energy coming from somewhere to push what? That particular object, right?
Yes, sir.
Push a body. So now, the same thing as when you what? When you pull, there's a contact. You understand? There's a contact and there's a what? There's a force. Do you understand? Now, under non-contact force, we have the what? This is where you talk about the force field. What did I say?
Force.
The force field, not force. The force field.
Force field.
Yes, the force field. Now, in this force field, there are no physical contact. There are no what? Physical contact. It just has to do with what? With forces. There's a force, but we don't have contact. Examples are the magnetic force field, the electrical force field. Hope you can see the board.
Yes, sir.
The magnetic force field, the electrical force field, and the what? And sorry, the magnetic, electrical, and what's that last one? What's the last one? And gravitational force field. And gravitational
Force field.
force field. Okay, these are the three major, although there are other ones, but these are the three major types of non-contact force. Are you jotting down? Hope you are jotting this one down.
No, sir.
You are saying no. Something we've treated. Aliyah, well done. Oh. Aliyah. Aliyah. All right. I want to rub up the board.
Sir, no.
Sabirat, welcome. Late comer. Sabira too. Sabirat,
Sir.
welcome. So we're just doing revision. For you to understand friction, you must first understand forces. And Sabirat, you know we've treated forces, unless you're not
Yeah.
in here. So I'm just going over it again. You understand? I'm just going over it again. Now you know that we all know the definition of force. That force. You all know the definition of force, right?
No, sir.
Force is that which enables a body to change its shape or its what? Its speed or direction.
Sir, force is what?
What is defined at which is defined as that which changes the shape, speed, or direction of a moving body.
It is defined.
It is defined as that which changes what? Which changes the direction, the speed, and the shape of a moving body. Of a what? Of a moving body.
Sir, which changes the direction of speed?
Let me write it. Have you written this one on the board?
Yes,
Yeah.
sir.
So do I say you don't need to write this contact force again?
Yes.
Yeah. Take and see the board. It is that which changes the shape, speed, or direction of the moving body. That's it. That is the definition of what? Force. And outside there are two types of force. We have the contact force and the what? And the force field. You guys are making me repeat what I've said. That's what you get when you don't come to class. Do you understand? So, do you understand? And I've explained what contact force is to you, Nofisat, haven't I? I've also told you what the force field is, haven't I?
Yes.
Okay. So the magnetic force field, that one simply has to do with what? The attraction of what? The attraction between what? Magnets. The attraction between what? Magnets. Now there's a law in magnet that, I mean, when it comes to magnetism, that says that unlike poles attract, unlike poles attract, and like poles repels. Unlike poles attract, and like poles what?
Repel.
Repels. What this means is that if you have a positive side, magnet, when it comes to magnetism, you have the positive side and you have the what? The negative side. In fact, all force fields, do you understand? All force field has a positive side and a negative side. Do you understand? All force field.
Yes, sir.
So now, when it comes to magnetism, you have the positive side and you have the negative side. Let's say this is for one magnet bar. Then this one too, you have the what? The negative side and the positive what? Side. Do you understand? Do you understand?
Yes.
Yes, sir.
So now, that statement that unlike charges attract, like charges repel, simply illustrated like this. When you take this positive side and this negative side, if you bring them close to each other, even before they get close to each other, you see that they what? They attract. Do you understand? They attract that movement. That is why when you hold two magnets, together and you just, when you bring them close, when they attract, when they attract each other, that means that what? They were unlike charges. The process at which they attract each other, that they stick to each other, means that what you did was what? Taking the unlike charges together. Nofisa, do you understand? Sabira, do you understand?
Yes.
Now when you have you can see the signs now, they've changed. You can see the signs they've changed. If I were you, I would just draw the two diagrams. Like I will separate two diagrams. Okay. Or let me just do it for you like this. Let me do it like this. Just look up. This one's their what? Like charges. Like charges. This diagram states that they are what? Like charges. So there's every tendency for it to what? Repel. Like charges repel. There's every tendency for it to repel. There's every tendency for it to repel. What does repel mean? That is, they can never stick together. That's when sometimes when you take a magnet, or when you take two magnets, and you try to join them together, you see they do not join. Sometimes I don't know whether you've tried it before. Yeah, who has tried it before? No, sister, do you hear me?
Yes, sir.
Have you tried it before? When you take two
Yes,
magnets,
sir.
yeah? Have you tried it before? When you take two
Yes.
magnets, you've tried it, okay. So you know what, you understand what I'm talking about. Sometimes when you try to join two magnets together and you see that they do not join, it is because you are taking you are taking the like charges. You are trying to bring the like charges together, and they will never join. They will never attract each other. Do you understand? They will never what attract each other. That's why they said like charges repel. Okay.
Yes.
Then I want to rub off the board now.
Yes, sir.
Eh?
You can.
Okay. So now when you take unlike charges now, when you take unlike charges, huh? When you take unlike charges together, like when you try to bring them together, they get attracted to each other. They get attracted to each other. That is, they tend to what? They tend to join together, right? So now
Yes.
that is because they are unlike charges. And unlike charges, what? Unlike charges
Attract.
attract. Yes. Unlike charges attract. So that is just the force field around magnetism. That's the force field around magnetism. Okay. So now, where do we make use of magnets? Where do we make use of magnets? Where do we make use of magnets?
Sir?
Where do we make use of magnets? Where do you see magnets mostly? Where do you see magnets mostly?
Inside radios.
Yes, very good. Inside what? Radio. Which other device?
Television.
Yes, like that. Anything that has to do with what? With anything that mostly has to do with sound waves. That has to do with sound. Okay, that's where you see magnets usually. Do you understand?
Yes, sir.
Okay. So let's move on. You know this is revision. We've done it before. Before you have to understand force before you understand friction. If you don't understand force, you won't understand friction. Do you get me? Okay. So now the gravitational force. The gravitational force. You are conversant with this word. Anything that goes up must what? Eh?
Sir?
Anything that goes up must do what?
Must come down.
Yes, must come down. That is a layman's understanding of gravity. Do you understand? That's the layman's understanding of what? Of gravity. Now we are going to explain what that actually means. What that actually means, that what goes up was what must come down. So now the process at which what goes up comes down is due to the fact that the Earth's surface, the Earth's surface or the Earth itself attracts object towards it. The earth itself attracts what? Object towards it. Do you get what I'm trying to say?
Yes.
There's a force that pulls objects towards it. There's a force that pulls objects down towards the earth. So now, and that force is called what? And that force that pulls objects towards the earth is called force of what? Of gravity. Force of what?
Because of God.
Force of gravity. So viewers, if you read this before, you don't need to write it. Okay. So viewers,
Sir,
did you hear what I said or not?
can hear you.
So now, I said the earth attracts all objects on this planet to itself. The force with which the earth attracts all objects is called the force of gravity or gravitational force. It is for this reason that objects above the earth falls down. Above the above the earth falls down. It is for this reason that objects above the earth falls down. Okay.
Yes.
So now that is why if we are to examine some objects, objects like for instance, let's take a stone. You know a stone is heavy, but then we have
Yes, sir.
like kite, balloons. All those ones are light, and feather. All those ones are very light. Okay. So now, do you know that it is possible for those two objects, maybe for instance a stone and a feather, it is possible for you to throw a stone, it is possible for a stone and a feather to get to the ground surface at the same time when they are thrown to the air or when they are released from above the ground at the same time. What am I talking about? The grammar is too much. You take a stone on one hand and you take the feather on the other hand, and you drop them together. It is possible that the two of them touches the ground at the same time. Do you understand me?
Yes, sir.
It is possible that the two of them touches the ground at the same time, irrespective of their what? Of their weight. Now, That can only happen when there are no external forces like wind to affect that feather. You know, a feather is very light. You understand? And you've seen a feather moving before. Once it moves what? Sideways. Mostly in an oscillatory motion, to and fro. Do you understand? It moves like this before it gets to the ground. See? That is because of wind. That is because of the external force of what? Of wind. Do you understand me?
Yes,
Yes.
sir.
Now, if if there's no wind involved, let's say it's a room like this, whereby there is little or no air at all in this place. You pick the two of them at the same time, above ground level, at the same height, and you drop those objects. You drop them. The two of them will get to the ground. The two of them will get to the ground at the same time. Do you understand? Or if you
Yes.
go to an open space where there is a lot of breeze and air or and wind, you understand? And you drop those objects at the same time, the stone will get to the ground before the feather. Do you get what I'm trying to say? Do you understand what?
Yes.
Huh?
Yes, sir.
Okay. So that is just a way to test what? To test gravity. That is the way to test what? Gravity. Now, the measurement of weight. The weight of a body is defined as the force of gravity on that body. So what this is telling you that you can measure the weight of a body through the what? The force of what? Of gravity of that particular body. The force of gravity of that particular body. And how do you know the force of gravity of a body? It is when the impact it has when it touches the ground. Do you understand? The impact it has when it touches the ground or any surface. Do you understand me?
Yes, sir.
Yes.
Like now, if you throw a stone now, if you throw it on a surface that is not that, maybe a very heavy stone, you throw it up and it comes down, and you throw it on a surface that is not that strong, you will see the impact. Is that that place cracks? Is that place cracks? Or you hear the sound, or you hear the sound to tell you the force at which the thing touch the surface. Do you understand me?
Yes, sir.
So now, the feather, if you throw a feather too on a surface that is not that strong, you won't feel any impact. In fact, you might not even hear sound. Do you understand me? You might not even hear any sound. So now that's why they said the weight of a body is measured by the what? The force of gravity of that body. Do you understand me? So now there's an
Yes.
experiment. There's an experiment to check. There's an experiment to check, and that experiment is is the use of what? A spring balance. What did I say? The use of what?
The spring balance.
A spring balance. A spring balance. How to use the experiment? A spring balance. That is, you have a spring. The spring must be what? Must be mounted vertically. Then you have the what? The body or the mass of the body. The spring and the what? The mass of the body. Don't mind my drawing, but you shall understand. You know what a spring is, Abby?
Yes.
So when you suspend that spring vertically and you attach a mass or a body to or an object, let me use an object because that mass, guys are just looking at me. When you attach an object to that spring and you want to measure the weight, you see the extent at which it stretches, the extent at which it what? It stretches. What does this mean? That is, if you have an object that is very heavy, the spring will slack. You see it as in extending vertically downwards. Do you understand? You see it
Yes.
extending like the object, like the object is pulling the spring. Hmm? The same way, that can only happen when you have different, or you can actually, how will I say it? You can actually know when you have different bodies, when you have different what objects with different masses. So that means you are not just testing an object with one mass. You are testing different objects with different masses. You understand?
Yes, sir.
Okay. So now, anytime you are dealing with work done of gravity, work done of gravity, I say work done of gravity. Anytime you are dealing with gravity, there must be a work done. Sort of. There must be a what? A work done. Anytime you are dealing with gravity, there must be what? A work done. That is MGH. Mass, where M is what? Mass. G is what? Where M is what? Mass. G is what? Force of gravity. Force of gravity. Then H is what? Height. Do you understand me?
Yes, sir.
Yes, I just looking at you. I need to know if you are following or not. Okay. So mass, gravity, and what? Is height. Okay. If you are dealing with gravity, like I said, there must be work done against gravity. There must be what? There must be work done against
Done.
gravity. What I say? There must be work done against
Mm.
gravity. Okay. So now that is that on that. Do you understand me?
Yes, sir.
So now we've talked on gravitational force field, we've talked on um, magnetic force field. So now let's treat electrical force field before we finally move to friction. You know we're supposed to do friction straight, but because of some people, that's why I'm going through this again. Do you understand me? Those that were not in the last class. Do you get what I'm trying to say?
Yes.
Yeah? No, I'm just revision. No, 10 minutes. We need 10 minutes.